Hello viewers, in today's class we are going to discuss another important problem from integral inequalities. And in this class we are going to discuss a very nice problem from integral inequalities in which we have to show that the absolute value of this integral, that is 0 to pi by 2 x times the square root of cosine x, is less than or equal to the square root of pi cube over 24. So to prove this inequality, we'll make use of an important result from definite integrals, that is known as Cauchy-Squarz inequality. Right? So let us first see the statement of Cauchy-Squarz inequality. See, if we have say two functions f of x and g of x defined in some interval, say a comma b, right, and fx and gx are both integrable and continuous functions, right? So now if the square of this function, that is f square, and the square of this function g of x are both integrable in the same interval, that is a comma b, right? So if f square and g square are also integrable from a to b, then the Cauchy-Squarz inequality says that the absolute value of the integral from a to b, f times g dx, is less than or equal to the square root of the product of these two integrals, right? So the first one is from a to b, f square dx, and then we have a to b g square, and here we have dx, right? So this statement is known as Cauchy-Squarz inequality. So here we have the absolute value of the integral from a to b, and here we have the integrand as the product of f and g, right? F and g, and here less than and equal to square root of the product of these two integrals. The first one is from a to b, f square dx, and then we have a to b in g square dx. So we'll apply this result to prove this integral inequality. So let us first denote this integral which is inside the mod function is by I, right? So I is 0 to pi by 2, and we have x times square root of cos x dx, right? Now see, if we compare this integral with this one, that is as a to b f times g dx. So if we compare these two integrals, we can easily see that a is 0, b is pi by 2. The lower limit is 0, the upper limit is pi by 2, and the function f may be taken as x, and the function g of x may be taken as square root of cosine x. We may also interchange the functions. Either we can take g of x as x or f of x as square root of cosine x. So now we can easily see that both these functions are integrable, and their squares are also integrable in the interval 0 to pi by 2. And moreover, x is positive in the interval 0 to pi by 2, and similar is the case with cosine function, because cosine function is also positive in the first quadrant, and the limits goes from 0 to pi by 2, right? So let us find out, or let us substitute these values in this integral inequality, right? So now see, we have here the mod of I, because this integral we are taking as I, which is our this integral 0 to pi by 2 x times square root of cosine x. So mod of I is less than or equal to the square root of the first integral, that is from 0 to pi by 2, and f square. So here we have f of x as x, so f square is equal to x square. So here we have x square dx, and the second integral is again from 0 to pi by 2, and we have g square. So g square is equal to the square root of cos x, and here we have square, right? So this is cos x. So here we have cos of x and dx. So now let us take this integral as I1, this integral as I2. So I1 is 0 to pi by 2 x square dx. So the integral of x square is x cube over 3, and here the limits are 0 to pi by 2. So we have 1 over 3 outside the integral, x cube 0 to pi by 2, right? So we have 1 over 3. Substituting the limits and taking the difference, we have pi cube over 8, because this is x cube, and here we have 0, so this is pi cube over 24, right? So now let us consider this integral I2. So I2 is 0 to pi by 2, and we have cosine x dx. So the the integral of cosine x is sine x, and the limits are from 0 to pi by 2. So this is sine pi by 2 minus sine of 0. Sine pi by 2 is 1, sine 0 is 0, so this is 1, right? So now taking the values of I1 and I2 in this inequality, we have mod of I is less than or equal to square root of I1. I1 is pi cube over 24, and I2 is 1, right? So mod of I can be written as less than or equal to square root of pi cube over 24, and this is our desired inequality.